Hello everyone. Okay, coming to the part 2 hydrology gate class. Today we will be discussing mainly on graphs. Okay, there are various graphs in hydrology. So we will be discussing about the various graphs and the importance of each and every graph for the hydrology. Okay, so regarding that first graph. Okay, so we will see the first graph. Okay, so what is the first graph in case of hydrology is hydrograph. Sorry, not hydrograph, hyetograph. 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 So what do you mean by hyetograph? Hyetograph is a graph drawn between the uh, two parameters. One is x-axis and y-axis. X-axis is duration of rainfall and t, and in y-axis we will be discussing about intensity of rainfall. So it is a graph drawn between intensity of rainfall and duration of the rainfall. So basically the hyetograph will be looking like this only. Okay. So this is one of the basic format of hyetograph. So in this we will be discussing about, this gives a value of about what, 5 index also. Okay. So this is the graph. Okay. So what is the use of the graph? Okay. So the in this graph, total area of the graph gives total depth of rainfall. This graph gives total area of the graph will be equal to total what, depth of rainfall or rainfall. Okay. So how does it mean? If you cut the area of the graph, it will like intensity. Area of the graph will be like what? Intensity into time, right? We know the unit of intensity is centimeter per hour, and duration unit of time is hour. Okay, we cancel. So outlast we can centimeter. Based on that, we can able to calculate depth of what? Depth of the rainfall. Total depth of rainfall. Okay. So in this graph, we were talking about phi index, right? The value of phi index will give, okay, what will give total amount of infiltrated water. It means total amount of water get into total amount of in infiltrated water. Okay, the value above the phi indexes will give idea about the water volume, total volume of water contributing to surface runoff. Okay, so the okay, the shade in this area, if you shade this region alone will contribute the value of total surface runoff. So therefore, shaded area in this graph will be giving the the shaded area will give information about depth of surface runoff. Okay, what? Surface runoff. Okay, so we in this we have to read about runoff coefficient. We have this runoff coefficient. Okay, so what we mean by runoff coefficient? It's indicated by C. It's a ratio of depth of direct runoff or runoff. Okay, divided by depth of depth of rainfall. See, this is a ratio. Okay, This value always lies within less than 1, always. Okay, so we can calculate discharge in runoff. Q runoff will be equal to Ci into A. This is a basic formula used for calculating discharge. Here discharge will be in cubic. What? Cubic. What is in meter cube per second? And I see for C no units. Okay. For I, intensity of rainfall is centimeter per hour. For area A, it is for area A, it can be like what? Kilometer square. Okay. So in this case, if you if you change a formula for purpose of calculation purposes, therefore Q is equal to CIA divided by 0.36. Okay. This is the value. This is about hydrograph. Okay. Okay. Next thing we will be discussing about hydro. Sorry. First thing we are discussing about hydrograph. Right. Next we will be discussing about hydrograph. So what do you mean by hydrograph? So it is a graph drawn between discharge versus time of flow. It is a graph drawn between discharge versus time of flow. So how the graph will be look like? Hydrograph is a graph drawn between discharge. Okay. So it will be like, okay. So this, okay. So discharge in y-axis and time of flow in what? In x-axis. This line indicate base flow. So it is hydrograph drawn between discharge and time of flow. Okay. So if you first in hydrograph we were discussing like the area of the graph will be giving total depth of rainfall. In this case, area of the graph will give area of the graph will give area of this in this unit. Area of the graph will be giving what? This will be giving volume of the direct runoff. Okay. How can we determine that? Wait, area of the graph will be giving volume of the DRO, direct runoff. Okay. So in this case of unit hydrograph, we will be considering, in case of unit hydrograph, we will be considering runoff depth is 1 centimeter. These are the points to be remembered. It's a unit hydrograph. So therefore here runoff is equal to off into time of wave into Q peak divided by area of the catchment. So okay. Next graph we'll be discussing is what? Flow mass curve. Next graph we'll be discussing is flow mass curve. This class will discuss flow mass curve. This curve is also known as next class is also known as ripple curve. So how this graph will be like? Okay, okay. Here the graph will be like, it will be more or similar to the like, though this gap is denoted by y2 y1. So in this y-axis it will be denoting like cumulative inflow. This is nothing but discharge into time. In y-axis it will give information time of flow about time of flow. Okay. So the y1 y2, what does y1 y2 indicate? The y1, y2 indicate about the reservoir storage capacity or live storage capacity of a reservoir. So what do you mean the live storage capacity is value of y1 plus y2 is equal to live storage capacity of the reservoir. Y1 want to indicate live storage capacity of the reservoir. Okay. Flow mass curve is also known as integral curve of hydrograph. Okay. So mass curve is also known as integral curve of hydrograph. Okay. Okay. Fine. So so far we have some three curves, three graphs. First is phytograph, next is hydrograph, next is flow mass curve or ripple curve. Okay. So next thing we will be discussing about mass curve of rainfall. Mass curve of rainfall. So it is a graph drawn between uh, in y-axis we will be talking about cumulative depth of rainfall, that is nothing but summation p, and in y-axis we are discussing about time of rainfall. Okay, so this graph will be like, wait a minute. So this graph will be like this one. So this, from this we can get dy dx. Okay, so here the tan theta, as well known as tan theta, is equal to dy by dx is nothing but intensity of the rainfall. Okay, okay, that's this is example of mass curve of rainfall. Next thing we will be discussing is double mass curve. Okay, so this is one of the important curve. It's similar to that of mass curve only, but with the help of this curve, we can able to check major two parameters. One is consistency of rainfall, how consistent the rainfall is. Next one is cumulative depth of rainfall of missing station, or cumulative cumulative depth of rainfall of missing station to the cumulative depth of rainfall of the surrounding station. Okay, of missing station to the cumulative, or sorry, cumulative depth of rainfall of surrounding station. Okay, so these are the two things which with the help of the we can able to determine in case of double mass curve. Next thing we will be discussing is, next after double mass curve we will be discussing about the DAG curve. Okay, this is a DAG curve. So DAG curve is also known as depth, area, duration, okay, just a minute. That's also known as depth, area, duration, area, duration curve. Okay, this is known as DAT curve. So in case DAT curve, this curve is depth of rainfall in y-axis, and duration with the area duration curve. Here area in x-axis. Okay, duration in this parameter. So like this. So it will be like 25 hours, 15 hours, 10 hours. This is depth area duration curve. So with the help of this curve, whenever time increases, we can see that slope also increases. So time is directly proportional to slope. In this case, we can consider about two scenarios. First thing is if time is constant, then area increases but depth decreases. Okay, depth decreases. Similarly, if area is constant, depth increases, duration also decreases. This can be determined by the area. For example, area in this point is constant. Okay, area is constant. We are keeping area constant in this parameter. Okay, okay, area is constant. If you look at the depth for each and every time, the depth keeps on increasing. So depth is directly proportional to, okay. Okay, this is depth area duration curve. Okay. Next thing we are going to discuss is next thing we will be discussing about is rating curve. So rating curve is also known as stage discharge curve. This is known as stage discharge curve. So it is a graph drawn between stage in y-axis and discharge in x-axis. Okay, stage in y-axis and discharge in x-axis. So this graph will be like this. Okay, the main purpose of this graph is to find discharge of the rain. Sorry, discharge of river during flood time. To find discharge of the river, especially during flood time. Okay, during flood time, this graph will very much useful. Next, for by finding depth of water, it also used to find depth of water, depth of water in the river. Okay, okay, fine. Next thing is we are on rating curve. Next, we are going to see about what envelope curve. Okay, next thing we are going to see is envelope curve. Okay, envelope curve is a graph drawn between discharge which is catchment area A. The graph will be looking like this. Okay, so whenever area increases, discharge also increases. It's directly proportional. So therefore, what area is directly proportional to discharge Q. This is envelope curve. Okay. Next thing is last graph, flow duration curve. Flow duration curve is also known as what? Flow frequency curve. Okay, this graph will be look like this only. Similarly, so what? Okay, so in y-axis we are discussing about discharge of the river. In x-axis we are discussing about percentage of time. Okay, so here it is 50 percentage and 70 percentage. Okay, this is discharge of the river of Q50. Okay, this is discharge of Q70. So here it will be like this only. So for 70%, here it will be like this. So okay. So based on the given graph, is shown as a discharge of 50 percentage much more greater than discharge of 75 percentage. Okay. Here a few things which has to be noted, like return period. What is return period? T is equal to n plus 1 by m, and the probability P is equal to 1 by T. That is nothing but m into n plus 1, where m and n are, where m is equal to rank of flood discharge. What is n? N is equal to number of years of record. Okay. These are the important graphs which we will be following in case of hydrograph. Next class we will be discussing about number of calculating optimum number of rain gauges, and how can we determine rain gauges. We can next class we will be discussing about rain gauges and optimum number of rain gauges. Thank you.